All right. Welcome back, everybody. Today, we're going to be doing some review of dictionaries and then introducing a new concept called importing. And we'll be doing a little bit of diagramming, a little bit of following along in code, and should be hopefully a nice recap of what you've already learned about dictionaries, and then we can start to understand some things that we've seen so far in the course, but haven't really had a good frame of understanding. Specifically, what is that weird name variable that we're checking to see if it's equal to main? We will get to the bottom of that mystery today. So I'm going to switch over to my laptop view, and we're going to begin with a code tracing exercise. I apologize for the size of this. My computer had problems. Let me see if I can oh, there we go. PowerPoint wasn't loading initially. But we're going to have this diagramming question where we've got two functions, and you'll see that there's a dictionary, or we're making use of dictionaries, dictionary literals, and some of the concepts we learned previously. So in just one moment, I'll make this full screen, and I'll turn it over to you all. I want to remind you that, nope, that's not it. If for some reason what you're seeing on these slides is hard for you to read when it's on the projector, I would encourage you to open up the slides off of the website, and I will make this full screen. There we go. We do have our TAs here today, so if you have questions, they'll be roaming around. And let's go ahead and spend a few minutes on this example, and do assume that the special variable name is assigned the string main for the purposes of this diagram. Feel encouraged to check your answers with neighbors or ask questions. Two more minutes on this, and then we'll work through it together. All right, let's start working through this together. I've gone ahead and set up my globals frame, and we've got main and merge. There's one other variable that we're going to be talking quite a bit about today that I want to add to globals that we don't expect you to have in globals. I'm just going to put it there because it does exist there behind the scenes, and this will become important later today. So this assumption that there's this variable named name implies that there's a global variable named name that is assigned when we ran this particular module as a program, the string _main, all right? And so far, whenever we've run a module as a program, this has always been the case, and whenever we've asked you to diagram, we ask you to make this assumption. We're going to learn that there are other ways in which modules can be evaluated later on in today's lesson. But for now, we're asking ourselves what happens when we run this particular module as a program. We Python-m and then whatever packages is in, followed by the module name. And so we load our definitions in, and then we reach line 21, right? And down at line 21, 22, we're testing, is there a variable named name, and is it equal to, are its contents equal to the string main? And of course, we're asking you to make that assumption, so that's true, and that's what leads to this call to the main function on line 22. There's nothing really special about this particular block of code here. This is just a common convention and idiom in Python that's used frequently. So when we call main, we jump up to line 5. And I'm actually going to change to blue here so that it's, nope, not that blue, visible on the projectors in the classroom, which are a little bit dull. All right, there we go. Great. So we jump to line 5, and we see that we have a variable being declared locally inside of main's context, or local scope. Right? So inside of main's frame, we're going to have a variable named game0, and it's going to be assigned whatever the evaluation of the right-hand side is. Well, we're setting up, this is syntax for a dictionary literal, right? So I'm going to set up a dictionary, and the key type is string, and the value type is integer, right? And so the order of these two, what we call type parameters, matters in this case. We're saying specifically that the keys of this dictionary have to be a string, and those keys are going to be mapped to, or we can look up values by them, and the values that are stored in this will be an integer. And we can see that there are two strings here, kj and ml. Oops. All right, those are two strings, and the associated values that those strings map to are 0 and 1 respectively. So I'm going to drop in my table here, and hopefully this wasn't too surprising. And as a reminder, the difference between, say, a dictionary and a list is that a list, its indices are always integers counting up from 0. With a dictionary, we get to choose what we look up by, and in this case, we're looking up by these strings. So now that the left-hand side of this has evaluated, we've established this object in the heap, we're going to assign a reference to that, to game0, locally in main's frame, right? So just like with lists, dictionaries are reference types. Those objects exist in the heap. Whenever we have names that refer to them, we actually are drawing arrows and we're thinking about references rather than the exact values, right? Same idea with game1. So I'm going to move through this pretty quickly. We have another dictionary. It's also string integer. And we've got the string ml, and it's associated with the value 2, and the string ew is associated with the value 3. All right, I'm not even going to draw in lines here. I'm going to be moving pretty quickly. All right, so this is game1. And we can imagine that maybe this is modeling the scores of games that were played. Just like with lists, where we draw the arrow to on this box doesn't matter. We're referring to the entire dictionary as a whole. Where things get interesting is on line 7. We see that we need to make a call to this merge function in order to know what to assign to the variable we're declaring here, named merged in the main frame. So before we make this call, we should probably just check and be sure it's a valid function call. Do we know what merge is? So we look for the word merge in our current frame main. We don't see it there, but then we look in globals and we see, sure enough, there's a function named merge. It's defined on these lines, so we've seen this definition before. It's loaded into memory. And then we check, okay, well, is the first argument, game0, what is game0? Game0 is a dictionary from string to integers. Turns out that is going to correspond just fine with the first parameter here, named a of this function definition. That's also a dictionary from string to integers, so that checks out. Game1 is also declared to be a dictionary string to integers. That's going to map to the parameter b, which needs a dictionary of string to integers. And then the last thing we need to check is the return value. So we see that this function is going to return to us a dictionary from strings to integers. And are we using this function call in the right way? Well, we're calling it, and we're trying to assign the result to this variable, whose type is a dictionary string to integer. And so there is a correspondence here that checks out, right? So the return type of this function matches how we're trying to use the function call. Okay, so let's go ahead and set up this frame. Just like with lists, we're going to be copying in references. So merge was called on line 7. And we need to set up our parameters, right? So A and B. What are our parameters? So what is A? And this is the question you need to be very careful of, but you all did fantastic very recently on navigating questions around references. So game0 in main is this reference, this arrow, to this first dictionary, right? So A is also going to be a reference to that same dictionary. And let me see if I can, I'm going to choose a slightly different color here to make this a little bit more obvious. So I'll choose red here. So A is going to be a reference to this dictionary. And similarly, we're copying in for this B parameter, whatever game1 is in main. So game1 is a reference to the dictionary with down here. So B is going to be, and I'll mark this in red as well, a reference to that dictionary. All right. So notice we didn't copy these dictionaries, we copied references to them, and that's important, all right? So we've copied our parameters in, we're ready to go. We jump into line 13. Here we see some kind of silly looking syntax, 2 curly braces side by side. What does that mean? Well, that means we have an empty dictionary that we're establishing on the heap. So this is a dictionary from string to integer that has no keys or values loaded into it yet, right? But whenever you see empty pairs of curly braces, we know that we're constructing a new empty dictionary on the heap that's separate from any other dictionary we've seen before. And what are we doing with that dictionary? We're assigning a reference to the variable named result. All right, so result is going to be a reference to this dictionary. And we're ready to go. Just for note-taking purposes, this syntax is exactly equivalent to, if we wanted to be a little bit more explicit, if we called, oops, not list, if we called the dictionary constructor directly with no arguments, this would also construct an empty list. There are 2 ways of doing the same thing. Right? But you'll frequently see people just use an empty set of curly braces to construct an empty dictionary. All right. We then reach a for in loop, and when we use for in with a dictionary, we're going to be looping through each of the keys in that dictionary. So here we're talking about for each key in the dictionary A. So the dictionary A, let me try and use purple here, has 2 keys in it, KJ and ML. So I'm going to keep track. You know, the first key that we're going to work with is going to be KJ. So I'm going to set up a variable locally named key and assign it the string KJ. Right? And that's what's going on in this very first for line, where we're saying for key in dictionary. We're going to be iterating through, so that key variable inside of this loop is going to be assigned each of the keys one by one each time this loop iterates. So this first iteration, key will be KJ. And then we reach the line where result of key is assigned A of key. Right? So we need to evaluate this line. And this is where we need to be very careful. Right? So result of key is the same as saying result of KJ, right, for this first loop. And that's going to be assigned A of KJ. Right? So I look up what is A of KJ. So A of KJ is the value 0, right? That's what's associated with the key KJ in this dictionary. So this would evaluate to 0. And we're saying result KJ is being assigned this value 0. So what is result in the current frame we're working in? That's this empty dictionary we just set up. When you assign a key to a dictionary, and that key doesn't yet exist in the dictionary, we're going to append that entry to it. So now we're going to have the key KJ in this dictionary assigned the value of 0. Right? So we've effectively inserted a key value pair into this result dictionary. We've copied the value 0 in for the key KJ. All right. The next thing that happens is we reach the end of this for in loop. So we go back up and we ask, do we have any more keys to process? Yeah, we just did KJ. We still need to do the ML key, right? So we haven't quite finished processing this dictionary. So the next key is going to be ML. And we reevaluate this line here that is result of key is assigned A of key, right? So the same line. We look up what is A of ML, right? So A of key simplifies to A of the string ML. We look that up, and that's the value 1. Right? So 1 is going to be assigned to result of key. We just learned that when you assign, so result of ML, the key is going to be appended to this dictionary, and its value is going to be 1. Right? And so that's the result of this inner result of key is assigned A of key, being evaluated again. Well, we've now processed or looped through each of the keys in the dictionary A, so this very first for in loop is completed, and we're about to continue on to line 16. Before we do, any questions on what we've seen here so far? Yep. Good question. So the question is, and I'm sorry, I don't know where the handheld mics are today, so I'll have to repeat the questions for those who are streaming. So the question is, do we need to write the key in this merge frame? And for our purposes, we wouldn't expect it either way, because technically that variable goes away as soon as this for loop completes. You couldn't use the variable key after the completion of this for loop. But if you want to keep track of it to know just what was the current value you're working on, that may help you, and I would probably encourage doing that over not, but we wouldn't check that either way, because technically, after this loop completes, that variable wouldn't be accessible anyway. Good question. Other questions? Yep.
So when you write for key in A, is it possible to rename key to any variable name you want? Does it always recognize that variable will be key now?
Great question. So the question is, when we write for key in A, can we use a different variable name here besides key? Yes, absolutely. You can use whatever variable name you'd like. We could have said for k in A, and that would have been the same. I did this to try and be explicit that we're talking about the key here. But yes, that's an arbitrary variable name chosen by you, the programmer. And as long as it's a valid variable name, you can use it. Yeah, good question. So something very similar is about to happen as we process the next for in loop, right? But notice we're saying for key in B. So we're going to be looping through the keys of this B dictionary. Its keys are the strings ML and EW. So it just so happens that the last key we processed was the string ML in the previous dictionary. That's a coincidence. You can ignore reading anything more into that. But when we start from the top of this next dictionary, the first key that we have is going to be the string ML when we look inside of this loop. And this loop is doing the same thing, except for we're taking what's in the B dictionary and copying it into result. And the very first time this happens, we need to be very careful. So let's think through this step more closely. So what we're saying is result of ML is being assigned B of ML, right? So we look in the B dictionary, and we see that that key is associated with the value 2, right? So we're trying to assign to result of ML the value 2. And now we reach an important question. What happens when we try and assign a value to a key value pair in a dictionary, and that key already exists, right? So result already has the key ML in it. And what happens is we're going to replace whatever the old value was, right? So ML is no longer going to be associated with 1. It's now going to be associated with 2, right? So when you assign to a key in a dictionary for the second, the third, the fourth, or whatever time, the most recent time you assigned a value to that key, that's going to be the value that's stored there. You're always overwriting a previous value that was stored associated with that key whenever you assign to a key. What happens in the very last iteration of this loop should be pretty straightforward. We say, OK, we just processed the key ML, so let's now process the key EW. And we go into the loop. We're pretty comfortable with how this loop works now. We look at B of EW, so that's the value 3. We're assigning 3 to result of EW. There's no key EW here, so we're going to append the key EW and have a value of 3 associated with it. And we've completed this for loop because there's no more keys. We went through the keys ML and then EW. So we've completed both for loops now, and we're ready to return the result. So our return value is going to be whatever result is. Well, what is result? Result is a reference to this dictionary. Our return value is also going to be a reference to that same dictionary, right? And we do expect when you're returning a reference to intentionally have that reference reflect an arrow from the return value to the object that you're returning. And where are we returning that reference to? Well, we're returning it back up to line 7, all the way back up in main, where this merge function call occurred. We're saying, OK, there's now going to be a variable named merged. And let me see if I can use a different color here to annotate this connection. I'll try green. That's going to be a reference to this dictionary that we just set up, right? The resulting dictionary. So merge is going to reference the dictionary with 3 keys in it. And we've completed line 7. The The very last line in main is we print merged. Well, when you print a dictionary, you get back a dictionary literal representation of it. So the output of this would be the dictionary literal, where we start with an open curly brace, and then we have the key KJ. And we use a colon to separate the key from the value. The value is 0. And then we use a comma to separate each of the key value pairs, is followed by the key ML. And its value associated is 2. And then the key EW has the associated value 3. And then the closing curly brace signifies the end of this dictionary literal. This is my output. All right. And then we reach the end of main. Main is just a procedure that returns none, so there's nothing left to do, and our evaluation of this module as a program has completed. At a high level, notice what this merge function is doing. We're giving it a reference to 2 dictionaries. It's copying all of the keys and values from the first dictionary into a new dictionary, and then all the keys and values from the second dictionary into the new dictionary. And in this case, if there's duplicate keys in both of the dictionaries we gave it, the keys that were in the second dictionary wind up winning out, the values that were associated with it. This is a design decision. You could imagine implementing this merge function and like throwing some kind of error saying, hey, you've got duplicate keys, we don't know what to do with that. You could imagine the first one winning instead and rewriting the program such that that was the case. But this is not an uncommon thing where you take 2 dictionaries and want to bring their keys and values together into a singular one, and here we produce that third dictionary. Questions on what we're seeing here? Yep.
If we append, say, we change the values right here, we set results of the index key equals A of the key. If we appended like ML equals 2, if we appended that value into the dictionary, that would cause a key error, correct?
So saying something such as result.append. So with dictionaries, there isn't actually an append method associated with it. I think there is a method for putting a key in the same way that we're doing it here, but you're expected to traditionally use it with subscription notation. Soon we'll look at some of the Python's official documentation. It turns out lists and dictionaries have lots of methods that are built into them that are capabilities that we're not teaching you because it's easy to go learn after you understand the fundamental concepts. There's a chance that there's a special method that says, hey, only insert this key if it does not yet exist. But otherwise, you can use the has operator to test. If the dictionary has this key, behave in one way, insert or don't insert, throw an error. Otherwise, go ahead and append it. And so you've got that control by being able to write your own if statement to test for a key in any case. Yep, question over here.
How would you have to change the function so that it adds both of them and doesn't the ML out twice? So you do ML twice.
So the question is, how could we have it such that ML is in the dictionary twice? And that's one of the fundamental features and limitations at the same time of a dictionary is you can't have the same key twice. We'll later learn that we could have a key associated with a list. So if we had a type such as a dictionary from string to a list of integers, right? So we'll soon see dictionaries that look a little bit more like this. We could have had multiple values associated with a single key if we appended those values to a list. But we would have needed to restructure our code quite a bit, and we'll look at that in a future lecture. But one of the fundamental constraints of working with dictionaries is you can only have one key value pair per key. The keys have to be unique, and unlike with lists where you can have duplicate values in it. Yep. So if result was an integer instead of a dictionary, this would have wound up being an improper function as defined. We could have maybe summed all of the integers along with that, but if I had tried to say return, if we had tried to declare a result as just an integer and assigned it an initial value of 0, this would have been an erroneous program that would have had many issues associated with it. Namely, when we go to return an integer, that breaks the contract that we're saying, hey, this function is going to give you back a reference to a dictionary that's a string integer map. But you could redeclare this function, maybe call it sum. It would be a sort of strange sum. But if we had said that it returns an integer, and maybe we go through and just add up all the values in both dictionaries, you could imagine doing something like that. But it would be a much different looking implementation, and the types would have needed to check out. All right. Great questions on this. So the next diagram is going to be a very quick one, and it should be very, very quick. And it should be very, very similar to the one you had, but much simpler. This time I want you to add the global variable name to your globals frame and assign it the string package.module and imagine what happens here, and we'll have like 2 minutes on this. Compare with your neighbors and go. I'll set up this name variable for you, and then you can take it from there. So what we're saying is on the stack, there's a globals frame, and the name variable is assigned the string package.module. All right? And that's set up for you, and then the rest of the question is, what happens when the rest of this module evaluates with that different assumption made? One more minute. All right, let's chat through this. So what happens in this example? Well, we do what we've always done. We reach this definition for main. We add an entry to our globals frame. It's the function. I'm not even going to write in the line numbers because we know how that works. Same thing with merge. Right? We declare a function. We store its definition somewhere so that we know that what we're talking about when we use merge in the future. And then we reach this if statement. And this if statement is testing if the variable name is equal to the string main, in which case that's false in this example, and we never call the main function. Our program just ends at this point, right? And this would be the diagram for this question. You're probably wondering, why in the heck would we ever be in a situation where this was important? Well, what we're about to see is maybe what we'd like to be able to do is from some other module or some other file in our project, we'd like to be able to import this merge function and reuse it without having to redefine it in both places. When we import a module, what's going to happen behind the scenes is this name variable is going to be something that looks like this, the package name dot the module name, rather than main. And so this will start to be, this is a hint at why we have this special convention for if name is equal to main. When we go and we import a module, which we're about to see how that works, it's going to behave differently than when we run a module as a program. And this allows us to have the best of both worlds in ways that we'll shortly see. So what we're going to do next is actually going to be a follow along in VS Code, and we won't need to diagram what's about to happen. So I might have you join me in code. And we see that in our workspace, we've got some directories we're now pretty familiar with. And we think of these directories as what we call packages. A package is going to be a collection of modules. And remember, a module is just a Python file. But when we're thinking about it in terms of code that it contains. So I'm going to set up a new module in my lessons directory and name this helpers.py. Right? So in my lessons directory, I set up a new file named helpers.py. And let's go ahead and just add a doc string here. Example of functions imported elsewhere. So as programmers, we like to solve a problem once and then reuse that solution in other places. And oftentimes, we'll set up some functions that we like to reuse in multiple modules. And we call those helper functions very commonly. So let's imagine a very powerful function, right? So I'm going to define a function here, a very powerful function named powerful. And it's going to raise x to the power of n, super powerful. We should never define a function to actually do this. But the point of what we're talking about right now is how to import functions. So I don't want to get hung up on a very fancy function. But you can imagine this is a much more powerful function than what we're implementing here. Its implementation will be very simple. Return x raised to the power of n. All right. So again, typically you would be doing this with much more significant and meaningful functions. Here we just wanted to get a very simple valid function that we can use elsewhere. All right. Nothing new, exciting, or fancy, or mind-blowing quite yet. But what we're about to do is make it such that we can have another Python file, import this module, and make use of its definitions. And here, we want to be able to call this powerful function from some other Python module. So let's set up one more Python module. In the lessons directory, I'm going to set up a file named imports.py. Right? And I'm going to drag the tab for imports.py to the left-hand side of my screen so that both of these can fit fully. All right, so on the left, so all I did was drag my tab for imports.py over to the left. You don't have to do this, but if you want to have them both side by side, that's fine too. So I'm going to add a doc comment here, or a doc string that says examples of imports. Right? So what we would like to do is import this helpers module. And the way that we're going to be able to do that is we need to sort of address it. How do we access this? Well, we know that it's stored in the lessons package. So we can say from lessons. And what are we going to import from the lessons package? Well, we're going to import the helpers module. All right. Now, if you save this, you might get an error that's saying, hey, you imported something, but you never actually used it. That's fine. You can ignore that. We're about to make use of this. So now that we've imported this module, we should be able to call the functions in it by saying something such as print helpers.powerful 2 to the 4th. Right? And so this is the simplest example of defining a function in a module and importing that module somewhere else such that you can use the functions and the other definitions in it. Right? So I'm going to start up my terminal and try evaluating this. So python-m lessons.imports. And what do you know? 16 is printed out. 2 to the 4th is 16. It seems like this works. We've now written a program that spans 2 files here. On imports.py, that's the module I just ran. We printed out the result of calling the function helpers.powerful, which was loaded in a separate module. So I want to talk about the actual mechanics of what's going on when an import happens using a memory diagram. But I want to emphasize that we won't ever have memory diagrams that involve multiple files in this course because it gets a little bit tricky. Nevertheless, let's try and imagine what's going on here. And I'm going to set up a new slide just really quickly so that I have something to draw on. And let me hide this. All right. So when we run the program, python-m lessons.imports, we know that we have a globals frame, and there's nothing in it initially. We just talked about this name variable. We'll come back to it, right? So what happens when we reach this from line, from lessons, import helpers? Well, what happens is Python says, whoa, 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 pump the brakes. We don't know what's going on in this other helpers module. We need to go fully evaluate it, right? So we pause right here. Eventually, we're going to have the name helpers in our lessons imports is going to refer to something. We don't yet know to what, right? So let's go figure that out. So what happens is, in lessons.helpers, we've got another globals frame. All right? And we start evaluating this module from top to bottom, just like we have been all semester long. Well, it's pretty simple what this diagram would look like. We just see one function definition for powerful. Right? So in this globals frame, we see the name powerful. And it's associated with a function definition. And I'm actually going to write in helpers.py. And let's say lines 3 to 5. Right? And this is our heap. Okay? And that's all that's in this globals frame in lessons.helpers. Right? We've completed the evaluation of this module. And now we're like, OK, Python says, OK, helpers is going to be bound to this globals frame. Right? So helpers, after we import it, it's going to be bound to any names that are found, or it's going to be bound to the globals of the file or the module we just imported. So now when we say helpers.powerful, that's what gives us access to the function definition in that particular file. And I'm not even going to evaluate this function call, but the same mechanics would apply. We would set up a frame for helpers.powerful. I'll just set up this very briefly. Helpers.powerful. And we would have a return address. We'd have parameters, set up all the good stuff, right? The key thing that we're focusing on is this idea of importing, right? And what happens when we reach an import statement like line 3? What happens is Python stops the program at that point. It goes and fully evaluates the module that we're importing. So it moves through every line of code in here. Here we just see a very simple module, singular function definition. And whatever's left in the globals frame is what we now have access to via that import, right? So we could extend this a little bit further, and we could maybe set up a global variable here, like a constant, such as the answer. And maybe it's integer, and I'll make a literary reference that some folks in here might get. The answer to life, the universe, and everything is the number 42, right? So if we imagine, OK, well, what would have happened when this diagram evaluated? We declared this global variable the answer. And of course, you all know that there would be now a global variable named the answer over here. And it has the integer 42 assigned to it. And if what I'm telling you is true and how this all works, then we should be able to reference helpers.theAnswer in order to reference the value 42 from over here in imports. Right? So I'm going to go ahead and print helpers.theAnswer from this file and try running it. All right, 16 and 42. Questions on what we're seeing here so far? Yep. Interesting. So the question is, could we print helpers, and what would happen? I believe what we're going to see, this is something I don't think I've tried, but I love demonstrating new things live. I think what we're going to see is something that says we have an object of type class module, because we're dealing with a module, and in theory, that's all of the contents of its globals frame. So if I were to try this one more time, yeah, we see module lessons.helpers, and then where that file was loaded from. There are ways, and this is beyond the scope of what you need to know, but just for funsies, there's this cool thing named dir that will show you everything that's actually in all of the names that are bound in that globals frame. You'll see there are some that are special to Python, but the two that we cared about, that we defined ourselves, are the answer and powerful, and everything else was built in. But there are ways of investigating, hey, what are all of the names in some module that we imported? Good question. Other question? All right. So I said to you that we would get to the bottom of why is it that we have this what's going on with this weird name variable. So in our imports, let's try printing double underscore. Let's try printing an f string that is imports.py, and then double underscore name, double underscore in, oops, and that should be lowercase. All right, so I'm printing an f string, and we're saying imports.py, and then we're substituting in this global variable that's built into Python, it's special, this name, okay? And I'm going to copy that line and put it at the very end of helpers.py as well, right? And in helpers.py, I'm just going to change it to helpers.py and then name, okay? So there's two ways in which a Python module can be evaluated. The way that we've been practicing all semester is this idea that we can run a module as a program by saying python-m and then reference the module. Right? The other way that we've just now learned that a module will get evaluated is when it's imported. And the main difference between these two things is just what's going on in this name variable. And we'll see that here in just a second. So if I run python-m, and then lessons.imports, and try and scroll up just a little bit. I'm going to make this just slightly smaller. All right. So this output is pretty interesting. The first line of output is this print statement in helpers.py. And so you're probably wondering, why is that? Well, remember, we're asking Python to run this module here on the left, and the first line is saying, hey, go import the helpers module. So we pause here, and we fully evaluate this module on the right. And notice the very last thing in that module is we print out helpers.py, and then whatever the name of this magical variable name is. And notice that it's lessons.helpers. It's the name of the package in the module. So when you import a module, this special variable is going to be the name of the module. That's different from when you run a module. That special variable will just be double underscore main, which we can see down here is the last line of output. On line 7, this name variable, when we ran imports.py as a module directly, it was main. So you might be wondering, okay, well, that's also true if we were to try let's ignore imports.py entirely. What if we ran this program or this module as a program? Right, so we can do that by saying python-m lessons.helpers. Right? And notice this time around, helpers.py printed out, yeah, you ran this as a module, so this special variable name was assigned the value main. So why all this trouble around the single variable? Well, this is why we have this convention. If the name is equal to the string main, then typically, we'll call main, and I might just add in a comment here that is Python idiom. Typically, you would call main here. But we'll just print that out, and we'll print, maybe ran as a program, or maybe evaluated as a program. And we'll also do something that's not very idiomatic, but we can add an else here. This is not a special if-else statement. It's just an if-else statement, and we could print evaluated as a module, as an imported module. All right. And so for the reason why we have this idiom that you'll see in programs throughout the semester and you've seen so far is it gives you the best of both worlds. It allows us to run this particular module as a program and have it do something meaningful, but it also allows us to import these function definitions in it, or these globals or anything else that's stored in the globals frame, without running that program, right? So without calling the main function in the way that we would normally do. So it's also, I'm going to say, typically not common to do anything in the case where a module is imported. So the idea is, when you import a module, you don't really want it to run you don't really want it to do anything. You just want its definitions to be loaded in globals. But when you run a module as a program, you probably have different expectations. You want it to do something useful, all right? So if we were to try running this program directly now, we would see that it prints out those first two lines. If we had a main function, we could call that main function, and maybe we'll do that in just a moment. But it's evaluated as a program when we say python-m lessons.helpers. So let's demonstrate that functionality one more time, now that we've added this if-else statement. So notice name is main when we ran this module directory. Lessons.helpers is this module that we're running. And that's one way that we can evaluate this module. And the other way that this module will get evaluated is when we import it, all right? So here, when this import line runs and this module gets evaluated, name will not be main, and we can prove that to ourselves by running that. And we see that the else branch is evaluated, and we see that this is evaluated as an imported module, all right? Questions on what we're seeing here? As your programs grow in size, you tend to have many different files that have related functions in them. And you'll import those modules elsewhere in your program to sort of build up larger and larger scale projects. All right. So the next thing I want to show you are a few other features of the import system. And then we might end with actually turning this into a more idiomatic program with a main function here as well. So it's kind of obnoxious if you have a long module name to have to type out this whole name each time you want to work with functions in it. So there's another way of importing another module, but giving it a new name that is specific to what you're working in. So we can also say from lessons, import helpers as, say, HP. And I'll make a comment here in my imports.py, import using an alias. Right? And now, anywhere where we had helpers before, we could just use HP, and these both wind up being references to the exact same globals frame that we set up in the helpers module when we imported it. All right? So we can illustrate this in memory if I wanted to, by saying, after doing that alias, HP is going to also reference this globals frame, and we have access to anything in it via the name HP. We didn't have to do the first line before that. We could have just done the second line and only used HP moving forward. You're free to do this multiple times. One thing I will note, though, is that Python is clever about this. If we were to try running this again, you might expect that this line print evaluated as an imported module is printed twice. It turns out it's only printed once because we're only going to load that module once. And then anytime we need to reuse it in the future, we just link back to its globals frame and have access to it. So if I were to run this one more time, we see that it's only, this module is imported and evaluated only one time, and then we can reuse it multiple other times in our program, no problem. All right. We can also import names directly from globals of a module, right? So what if we knew that we only ever wanted to make use of, say, powerful in the answer, and there are lots of other functions defined here? We can be a little bit more specific in where we're importing from. So we could say lessons.helpers import powerful, right? And if we do this, we can now, I'll add one more print statement, powerful, and say 2 to the 10th, a much larger number, right? So maybe I'll add some comments to these print statements as well so we know that what we're seeing. Access the first import. Access the aliased import. And then call the imported function directly. Right? So if you knew that you only wanted one function or a few functions, you can set up some imports like this that allow you to directly access it. And if we're wondering, well, what does that look like in memory? It's actually pretty straightforward. This powerful keyword, or this powerful word, would be bound directly to the function definition that was established in the heap, so we didn't have to go through helpers.powerful in order to get there, right? So when you import a value directly, you're copying that value, in this case a reference to the function, into your local scope. We could have done this, so if you want to import multiple names in this way, it's possible. We could also have imported the answer, that constant, in the same way by following it with a comma. So you can have a list of things that you import. And we could have accessed it very similarly now, print the answer directly. And we've established that name in our globals frame of imports.py. It would be bound to the value 42 there as well. Right? So I'll just reflect that in my memory diagram very quickly. So that would have said, OK, the answer is 42 here, right? So you have some flexibility in how you import and work with other modules. Typically, we're going to encourage you to follow the first two, but there will be cases where it's more handy and convenient to follow the third, where you're importing those names directly. What questions do you all have on the idea of importing names from other modules? Yeah, question here on the side of the back. Good question. How would you import a variable that's not in the globals frame? So it turns out you can't, and you'd have to somehow make that value work its way back into the globals frame of that particular module. And you've seen ways of doing this in, say, Choose Your Own Adventure, where you could have a function that gets called when that module is first loaded, has some local variable in that function, and then also have a reference to a global function that you can assign back to. And that would allow you to get around that limitation. But one of the fundamental ideas here is with imports, you're only going to have access to what's in globals when that module evaluation completes. Good question. I think there's another question over here. Other questions? All right, so let's bring this home really quickly with what's considered best practice as we've been seeing. So we should add our idiom to this imports.py for this if name is equal to main. And then we should maybe refactor this helpers.py just a little bit as well. Before I do that, I want to mention one thing that I kind of glossed over. When you're making these import statements, they need to be at the top of the scope that you're importing to. So we're importing into the global scope here. So they all needed to be at the top. If I had had one of these statements move down after others, so if I just copied and pasted here real quick, you would see that there's this error, and it says a module level import is not at the top of the file. It should be there. And it's best practice to organize your code in this way. It's not necessarily required, but this makes your program much easier to understand because, again, all of these names are working their way into the globals frame of this imports file. And it's helpful to know, well, what did we mean? What do you even mean when we say hp.theanswer? Where did that come from? Organizing your code such that these imports are all at the top of the file makes that easier to identify. All right. So let's try adding a main function here. So def main returns none. And I'm just going to tab indent all of the code that we had printed below it, and then add the convention here, which is if name is equal to main, then we would call main, all right? And now you know sort of the rationale for this pattern. One of the things that's kind of funny, if we like carried this forward and tried to import this imports file somewhere else, what would we be able to have access to? Well, all of the names that we imported into it, because they were all in globals. So this continues to work. You can have one module import another module, which imports another module, and so on. There's no limitation to that. And the same process applies. When you import a module, that entire module will get loaded and evaluated with the name variable being set to the name of the package and the module name, right? So we could also have a main in our helpers.py file, right? So I might declare it just below the answer. And maybe here we would just print something like powerful of 2 to the 16th. And maybe I'll cut and paste those lines that we were printing before and replace it with a call to main, right? So in helpers.py, I made a few changes here. I set up this main function that's very classically just a parameterless function that returns none. And we tried calling our function named powerful, and we're printing what we were printing before. And then in this idiom, I went ahead and called the main function. If we were to imagine what this now looked like in memory, we would see two changes that are important. First, there would be a main function in the globals of lesson.helpers, so helpers.py. And that's, I'm not even going to write it the lines. And there would also be a main function in the globals of my imports file, right? And this would be in imports.py. And that's totally fine to have two functions name the same things in two different modules. Python's not going to get confused. They're declared in separate scopes. And what we see is this main function and helpers would only get called if we ran this as a module. Otherwise, nothing would happen. And I'm actually going to go ahead for best practices and just comment out this else. And this leaves us with what we would think of as a pretty idiomatic module in both cases, where both of these modules can be run as programs, in which case the main function would be called in either. And either could have their globals imported elsewhere. There's nothing really valuable to use from this imports.py file, but you could import what's in its globals elsewhere too. The big idea in imports is really what's going on in helpers.py. Imagine we had tens or hundreds of useful functions that were related to one another that we had in a module, and we wanted to be able to use them elsewhere. Typically, when you import something, you don't really want any output to happen. You don't want things printed. You just want those definitions loaded such that you can access them and make use of them. And that's what's happening based on how we structured this file. And that all winds up being thanks to this very special variable named name, being set to one thing if we run a module as a program, and set to something else if we import it as a module. Questions on this example? In future exercises and projects, we'll be setting up some helper files in one Python module and importing them into the programs that make use of them in another, such that we can get reuse out of these functions that you're writing in many different parts of your programs without having to go copy and paste or re-implement them. So once you've solved the problem once, you're hopefully done. Got a question here, yep?
So what exactly is occurring at lines 18 to 21, helpers.py?
So on lines 18 to 21 in helpers.py, it depends on which way we ran this program, right? So if we ran imports.py, and let's just do that really quickly. So lessons.imports, we run that. And what we see is only this output in main on helpers on imports.py is being evaluated because this name variable is actually set to what we're seeing in this diagram. Oops, I didn't add that in, so let's add that in here. So there would be this name variable that's automatically established when we imported this module that was lessons.helpers. Right? So the idea is when you import a module, that name variable is not main. And so that's false, and nothing actually happens. So it's just like that second diagram we did where our function definitions were loaded into globals and then nothing else. And that's kind of what you want to happen when you import a function or when you import a module. You just want its definitions to load. You don't really want it to do anything else so that you can call it.
It doesn't run or anything. It's just an area where you hold the definitions where you can call at other.
Yes, so this is set up such that if we import helpers, nothing happens. But if we ran helpers, so python-m lessons.helpers, we would see that that main function is called when we ran this as a module. So this is what gives us the best of both worlds. We can run this as a program, and what happens in main is what's going to be evaluated. But when we import it, main doesn't get called. Yep, that's the key difference. All right, question in the back here. Yep, go ahead. So in the event that there's a module issue, it probably has something to do with potentially a typo somewhere or potentially the directory you're in the terminal. It's a little bit hard to debug in real time, but we might be able to help you right after class if you want to come up and we can look at that. Yeah, question here. Oh, that's actually a great reminder. So the green triangle is might be a blank triangle. That may have worked so far in the semester for you to run a program, but you really have to, for this to work, this -m, like running your module in this way, is important for evaluating your program in order for these imports to work in the way that are expected. Good question, and thanks for that observation. All right, so class on Tuesday will be asynchronous, and for both today's lesson responses and Tuesday's lesson responses, you'll have some extra time. I know it's been a really tough time on campus, and I appreciate you all hanging in there, and hope you're doing what you need to do for yourself to make it to fall break. With that, I'll see you all on the other side of fall break.